Hello, in this video, I'm going to give a walkthrough of this notebook, which is TensorFlow Custom Components. Um, so I would just go ahead and start running one cell after the other and give a quick um, content of each code cell of like what am I doing. I would run the first cell. This cell actually imports all the required libraries that are further required in this notebook, which are like um, import TensorFlow, Keras, NumPy, Pandas, Matplotlib, Scikit-learn tool, and also have set the seed here. Next, which is data preparation. Here we can see it loads California housing data sets and splits it into train, validation, and test, and then standardizes the feature. We can see the split data, which is train, valid, and test, and its respective value, and also this table for all the reference. Next is helper function for training, plotting, and comparison, which defines compile and train, then plot history, which summarizes the run, and then compare the results. So this cell helps us avoid repeating the same training and evaluation logic multiple times. Next, in this defines a simple dense neural network, uses MSE loss, MAE, RMSE metrics, trains baseline models, plots history, and summarizes the results. So we can see like then I train the baseline model, plots its learning curves, and save it results so I can compare it later with the custom components model. Yeah, these are the graphs that are plot as a result of this code cell run. We can see how the comparison between baseline regression loss and the metric. Next cell, here we create a custom Hubble loss and custom Hubble metric. Hmm, so we'll see this custom metric tracks the same idea during evaluation. I also include get config we can see method so these custom components can be serialized properly. Next, this cell is an additional custom model component. Here we define multiple like classes. We can see custom Glorot initializer, regularizer, and non-negative constraint. So this cell shows how different parts of neural network can be customized beyond just the loss function. Next, here I build the custom component model. This model uses the custom activation function, custom weight initializer, custom L1 regularizer, and non-negative weight constraint inside the dense layer. It also uses the Hubbard loss and Hubbard metric during training and evaluation. Then I train the model, plot its learning curve, so I compare its performance against the baseline model. We will wait for the model to load. Yeah, so this is the comparison, custom component model loss, and the metric. In the final part, I'll just run them again. I compared the baseline model and the custom component model, which we can see here using a results table. Then I plot the metric, test metrics such as test loss, test MAE, test RMSE, test custom Hubbard. This gives a clear final comparison of the how custom test TensorFlow components affected model performance. Overall, in this notebook, I have demonstrated so far of how to create and custom TensorFlow components, including a custom loss, custom metric, custom activation, initializer, regularizer, and constraint. Then I compared the custom models with the standard baseline on the California housing regression task. That's it with this collab demo. Thank you.